and good day, Algebra. We are going to move through PO9, our first objective of Unit 2, very quickly because there have been some requests to go over the math packet today as part of class. So we will get through this as quickly as we can so that we can accomplish that as well. So we start off Unit 2 with a power objective, and you only have two POs in the unit, the very first one, which is kind of the intro to it, and the very last one, which is the summary of it. Everything in the middle kind of builds from this or builds up to that. So it's about exponents and powers. What is an exponent and power? We know what it looks like. It's that little raised number, after another number, a variable. What is it? What does it mean? Sarah? Oh, I heard you say something, so I thought maybe you were gonna. What does an exponent mean? What's its purpose? What's it used for? Yeah.
A number by itself.
Okay, so its essential purpose is for repeated multiplication, right? Why write 7 times 7 times 7 times 7 times 7 when we can instead write that as 7 to the 5th power? So the purpose of an exponent is to show repeated multiplication. Okay. In the beginning, it was just addition and subtraction, right? And then people like, well, what if I want to, add 6 5s together? Oh, well, let's call that 6 times 5, right? Well, what if I want to multiply 5 6s together? Well, let's call that, what would that be? 6 to the 5th power, okay? And then division, of course, just repeated subtraction, right? So this is kind of as you move through the order of operations, the things that we have make everything else easier. And in this case, it's the repeated multiplying. What is the base in this context of an exponent and exponent expressions? The base, Aiden?
Like the whole number that's like the first number?
Yeah, it's the number or variable that is attached to the power. Okay? It's the number or variable that's attached to the power. It's what's being multiplied over and over and over again. Okay. So in some examples here, if we have x to the 4th, or in our 7 to the 5th from up above, or if we had, y to the 12th, right? All of those would be the bases. It's what's being taken to the power. We also have coefficients. We've talked about coefficients in the last unit, and we said they're the number that comes before the variable. Okay, it kind of tells us how many of the variable we have. In this case, the coefficient is a number that comes before the base. Okay, it's a number that comes before the base, and here's the kicker with coefficients. They are not affected by the power. Okay, they are not affected by the power. We'll come back to that shortly. In PO9, and actually pretty much every objective after this, you're going to be asked to write things in expanded form. What does it mean to write an exponent expression in expanded form? For example, this x to the 4th here, what would x to the 4th be in expanded form? Lauren? Yeah. Just what does the exponent mean? It means we're taking x times itself, and we got 4 of them, all being multiplied together. Okay. If we throw in a coefficient, I guess we didn't put an example in the last one here, but if we had something like 2n cubed, okay, the coefficient in this case would be 2. If we were to write that in expanded form, 2n cubed, what would that look like? expanded form, 2n cubed. So writing it not as not with a power, but as repeated multiplication. Yeah.
2 times n times n times n.
Very good. That you only said that 1, 2. That coefficient not affected by the power, even though we have a power of 3 in that term, there's only 1, 2. Okay? That exponent is attached to the base, which is the n, not the coefficient 2. Not the coefficient 2. Why would that be? Why wouldn't that 3 apply to the 2 as well? Why only the variable here? Aiden?
Is the variable's the base?
Variable's the base. Lila?
You're taking n cubed times 2.
Okay. It goes back to PERMDAS, right? Order of operations. Exponents come first. So we have to cube that first, which is that n times n times n, and then we do the multiplying by 2. So what we're going to see in PO9 here is a lot of practice with identifying what's the power attached to, what is it not, what's the coefficient, what's the base, and then also how parentheses can change that. Okay, so kind of back to order of operations here as well. Any questions so far though? All right, very well. So going on down to the Mr. Happy Pencil section, who's so happy to give you an opportunity to practice this. Says for each term below, identify the coefficient, the base, and the exponent. Then write each term as an expression in expanded form. Finally, evaluate the term when n is 2 when you do have an n. So just because I've got different colors to work with here, I'm going to underline my coefficient in green. My base will be in blue, and my exponent's power will be in red. If you've got different colors to use, you can do that too. Otherwise, you can use letters or whatever you want to do. But in 2n to the 5th, coefficient, oh, I wrote the word red. It's not very helpful. Coefficient, base, and power. Which one can you give me? Identify 2n to the 5th. What's our coefficient? What's our base? What's our power? Maggie.
The power is 5.
Power is 5. Underline that in red. Okay. How about the base? What's our base here? Noah? The n. And that makes our 2 a coefficient, which is not affected by the power. So the example that we had above, that was 2n cubed, which was 2 times n times n times n. This is very similar to that. We only have that 1, 2, and we've got 5 n's that are all being multiplied together. Okay? So that's the expanded form. We now need to evaluate this when n is 2. So I'm just going to replace all those n's with 2's. And so essentially we end up with 6 2's all being multiplied together because our coefficient happened to be a 2 as well. How would you go about multiplying that out? First without a calculator, then we'll talk about how to do it with a calculator because you will be able to use one on this test. How would you multiply all those 2's together without a calculator? What would your strategy be? Gigi. Sure. So Gigi's saying, I know that 2 times 2 is 4, right? And I essentially have 4 times 4 times 4. Maybe for some of you that makes it easier. Maybe for some of you don't quite know what 4 times 4 times 4 is. Okay? How else could we group these 2's? Rather than kind of 3 4's there, how else could these 2's, that's some precision erasing right there. How else could we group these 2's? That would help us to multiply this mentally. Yeah? Sure. 2 times 2 times 2 is 8. And then another 2 times 2 times 2. 8 times 8 is a pretty basic fact, right? Or you could just go straight across, just double 2, 4, 8, 16, 32, 64. Okay? So lots of different ways you could do it mentally or logically here. How would you do it with a calculator other than putting in 2 times 2 times 2 times 2 times 2 times 2? What's your exponent button on a calculator? Leah? Yes, good. What does the exponent button look like on your calculator? If you've got the recommended calculator for the course, which looks like several of you in the front row have here, and Maggie's got it there, okay? What's the exponent button? If you want to take something essentially to the 6th power, which is what we have here, 2 to the 6th power, yeah.
Doesn't it look like kind of an X with a little variable like on the top of it?
So there's a Y to the X button, which you could use. There's a more efficient way, a more standard way also. Right above the X squared button on your calculator is a button that looks like this. It's got a little, it's called what's a caret. It's above the 6 on a keyboard, if you ever, yeah. But that's kind of your to the button. So for 2 to the 6th power, which is what we have here, we would do push your 2, then that caret button, and then 6. And that's going to take 2 to the 6th power, and you should get 64 if you do it correctly. Awesome. Yes, Leah.
I don't have a caret button.
Yes, you've got, I think you do actually. I just don't think it's above the X squared button. That's the same calculator that I have, and there is a to the button on there somewhere. It is above the division symbol.
I see it.
Yeah. Okay. Negative 10n cubed. Give me the coefficient, give me the base, give me the exponents, whatever you want. Aiden.
The base is n, the coefficient is -10, and the power is 3.
The base is n, the coefficient is -10, and the power is 3. Absolutely correct. Okay? So then writing this in expanded form, because that -10 is a coefficient, it's not part of the power. We only have one of them. And then we have n times n times n. Okay? You're asked to evaluate this when n is 2. So we're going to replace those n's with a 2. And here's one you can do mentally, in the sense that if you know that 2 times 2 times 2 is 8, it becomes -10 times 8, which is -80. If you use a calculator, then you can type it in. You don't have a -10 button, but you press -10, and then times. You could do 2 to the 3rd. Your calculator will automatically do the 2 cubed first, and then multiply that by -10. You should get -80. Okay. How about the next one? 3 to the 4th. 3 to the 4th. Coefficient, base, exponents. Give me any or all. Aiden.
I have a question on the last one.
Yes.
Wouldn't it just be easier at that point just to do -10 times 2 times 2 times 2?
Sure. What do you want to do? Yep. Whatever you want to do. 3 to the 4th. Coefficient, base, power. What do you see? Where is it? Lauren. The base is 3. Okay. 4 is obviously the exponent, right? Do we have a coefficient here? Not really. Okay. Remember that the base can be a number as well as a variable. If you were really pressed to name a coefficient and say, there has to be a coefficient, you must give me one, what would you say?
0.
Wouldn't be 0, because that means that we're taking 0 times 3 to the 4th, which would wipe the whole thing out. 1. Yeah. If you had to say coefficient, you would say 1 here, but saying there isn't one is just as acceptable. And so in expanded form, 3 times 3 times 3 times 3. How could you mentally calculate this fairly easily, just going off of basic facts and what you know? Sure. 3 times 3 is a 9. 3 times 3 is another 9. 9 times 9 is 81. If you wanted to do 3 to the 4th in your calculator, that would work too. Okay. How are we doing so far? Huh? Now we get our first introduction to parentheses. Okay. And so in this case, what are the bases? Plural. The bases of n cubed and then that quantity squared, which is what this is saying. Whenever you have an exponent, you have to have a base, right? It's got to be attached to something here. So what's the base for our exponent of 3? Aiden?
The base is n.
N. But then we have that second exponent there, that power of 2. What's the base for the power of 2? What's being squared, Pierce?
Whatever you get from the answer.
Right, all that inside the parentheses. Okay, so when we write this in expanded form, we can kind of start on the outside and work our way in. Okay, what's being squared is n cubed. So we have n cubed times itself. Right, n cubed squared is n cubed times n cubed. But then, to go even further here, in each set of parentheses, how many n's do we have? In each set of parentheses, how many n's are being multiplied together? 3 of them. So to go even further, we have n times n times n times n times n times n. Right? We started with this exponent on the outside. We said, what's being squared? N cubed times n cubed. Then we said, okay, what does n cubed mean? Well, that's n times n times n times another n times n times n. And since we're just multiplying straight across here, there's no other operations. We don't need those parentheses. They're helpful to kind of break it down, but now we can remove them. And we end up with the same kind of 2 to the 6th power, if n is 2, that we had in the first one. 64. So what parentheses do is they affect the base in the sense that they either create multiple bases, like it did here, or if you look in the one in the 2 right below, we've got 2 very similar expressions there. The only difference is that one of them's got parentheses and the other one doesn't. In that first one there, without parentheses, negative n to the 4th without parentheses, what's the base? Negative n to the 4th without parentheses, what's the base?
Negative n.
Not that negative sign, right? It's tricky because that negative is really the number what? We saw this with the distributive property as well. And we've got just a negative sign outside of parentheses. What are you distributing in?
1.
Negative 1, right? And so this negative sign actually acts as the coefficient negative 1. You could rewrite this to be negative 1 n to the 4th, to where you've got that coefficient of negative 1, that base of n, and the exponent of 4. Meaning that when you write this out in expanded form, how many negative signs will there be? Just the 1, because that negative sign is part of the coefficient. So in expanded form, it'd be negative 1 times n times n times n times n. With parentheses, however, like the second one, what's the base of that 4? Say what you said earlier. Negative n, right? What changed? The parentheses did. The parentheses are saying now include that negative sign with the exponent. Okay? So in this case, in expanded form, it's negative n times negative n times negative n times negative n. You'll see this affects the final value because when we plug in 2 for n, which is what we do to evaluate it, in the first one without parentheses, we've got negative 1 times 2 times 2 times 2 times 2, which equals what? Negative 1 times 2 times 2 times 2 times 2. Yvonne? Negative 16. Right? In the second one, that negative sign is part of the base. It's a -2 times -2 times -2 times -2, which is what?
Positive 16.
+16. Okay? The parentheses do matter. The parentheses change what's being done. You must pay special attention to parentheses as far as what they include with the base. When there are no parentheses, what's not included with the base. Okay? In order for a negative sign to be part of the base, it needs to be in parentheses. All right? Questions on any of that? All right. Second page. You are asked to do basically what you did on the first page here. It says write each term below in expanded form, then evaluate for n is 2 and y is 3 when you've got variables for n and y. Taking a look at this, are there any that you want to do together? Any that, I mean, you got some fraction stuff down here. Maybe you want to talk about those. You got some with parentheses. Any that you want to go over? Sasha? Sure. So 10y to the fourth over 5n to the fifth. Our first step is going to be to write this in expanded form. So even though it's a fraction, that's right. Deal with your numerator first. I've got a 10 and then 4 y's. That 10 being a coefficient, there's only one of them. It's not affected by the power. It's not part of the base. And then my denominator would be what? Who can tell me what my denominator is going to be here? 5n to the fifth. How do I write that out in expanded form, though?
5 times n times n.
Right. You just get that 1, 5, and then 5 n's all multiplied together. Okay. Now, your next task is to evaluate this when y is 3 and 10 is 2. So my numerator becomes 10 times 3 times 3 times 3. Did I say 4 of them? Times 3? I don't know. Anyway, you got 4 3's now plugged in there. And when n is 2, 5 times 2 times 2 times 2 times 2 times 2. So often, folks get just thrown off by fractions because you think you have to do the whole thing together. You really don't. You know, you can kind of just work with the numerator and the denominator separately until the very end when it's time to simplify. You know, it kind of makes this a little bit easier not to do the whole thing at once. And so what does our numerator equal here? 10 times 3 times 3 times 3 times 3. Don't need a calculator for this. If you remember that, you've got a group of 3 and 3 here, which is 9. Another 3 and 3 here, which is another 9. Essentially, you're taking 10 times 9 times 9. Or if it's easier, 9 times 9, and then times 10. What do you get? Aiden?
Would it be 1081?
Nope. 9 times 9 is 81. Multiply that by 10. What do you do to something when you multiply by 10? Maggie? What did you get as an answer? Is that what you're going to say? 810. Yeah. 9 times 9 is 81. If you multiply 81 by 10, you just get to add a 0 on there. Now, that's our rule for multiplying by 10. Just put a 0 on there. And then in our denominator, 5 times 2 times 2 times 2 times 2, well, I can kind of break this up. I know that 5 times 2 is 10. 2 times 2 is 4. Another 2 times 2 is 4. What's 10 times 4 times 4? Or, if it's easier, 4 times 4 times 10. Sasha? 160. Okay? So I've been solving this fraction just piece by piece. I haven't combined anything yet. Now I get to simplify it. And what is your first, the obvious way that we want to simplify this? 810 over 160. Annika? They both end in a 0, so we can get rid of those right off the bat. And we're left with 81 over 16, which has no more common factors, and so we can't simplify any further. Okay. So in addition to coefficient, base, exponent, expanded form practice, a lot of number sense going on here too. How can you sometimes mentally calculate powers? Just kind of break it up into basic facts, kind of like we did here. Okay. Any others? Any others? Yeah. The 4 squared over n to the fourth. Okay. So 4 squared over n to the fourth, in expanded form, 4 squared is 4 times 4. And then n to the fourth is n times n times n times n. Right? Now we get to evaluate this, which means we're plugging in 2 for n. Nothing really happens to our numerator. There's no variables to plug in for there. Right? So it stays 4 times 4. Then n times n times n times n is going to be 2 times 2 times 2 times 2. Will, numerator, 4 times 4.
16.
Denominator, 2 times 2 times 2 times 2. Ifan,
16.
how does 16 sixteenths simplify? Or anything over itself simplify? Lauren, equals 1. So that would be your final answer. Okay? So, writing out an expanded form, plugging in the values for the variables, and then simplifying or evaluating it. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Yes.
Have you posted anything on your ASMR?
No, there's another. I made the channel. There's another ASMR channel already out there that deals with math, and so I have to find my niche. I have to analyze that person's videos and find where I can insert my own flavor. Anything else? Not to end the lesson on a downer, but yeah.
Have a star. Have one of us featured in every ASMR.
Feature you doing what? Like, or you be doing the ASMR? So I like be the host. It's a possibility. Have your people talk to my people. We'll go from there. All right. This is homework. Due tomorrow. The rest of PO9 due tomorrow. That is High Math.